Hello, everyone. We are gathered here for the ARM Dev Summit, and this is Rishi Raj Maulik, Director of Product Management from Redis's Mobility Engine Business Division. We'll be talking about 5G network deployment use cases with respect to telcos and private 5G. The quick agenda for our discussion today is going to be a quick recap of 5G as a technology, what are the benefits and the pros and cons that the technology in itself is going to bring onto the table. And then we are going to quickly dive into the different 5G deployment use cases, which are coming with a lot of traction and momentum right now with respect to private 5G around the use cases of industrial automation and Industry 4.0. What are the synergies between 5G, the private 5G and the unlicensed spectrum? How does private 5G is going to fuel in a lot of the enhancements that are coming into the market with respect to edge computation, and how network slicing is a critical piece that 5G is enabling with respect to telco and private 5G deployment use cases. And last but not the least, of course, a quick snapshot of what we at Redis's Mobility Engine Business Division are doing with respect to our 5G and our solution offerings, with respect to the overall discussion that we have for this ARM Dev Summit. With that, let's quickly start with a quick recap of 5G. Of course, this is the next generation wireless technology. Traditionally, we've been talking about 2G, 3G, and 4G use cases, which were for give or take different reasons, but more focused towards operators and mobile network operators looking at different sorts of enhanced mobile broadband speeds. So basically, when we start with 2G, we have speeds in, let's say, just for the sake of discussion, on X Mbps. And then when we move to 4G, there is Y Mbps, which is obviously much more higher than 2G. Then we move to 3G, and then we move to 4G. But when 5G came into the picture, we started looking at a very different architecture, at a very different wireless technology, which is not just focused on one particular vertical, which is the public sector, where the mobile network operators are coming onto the picture. But 5G as a technology has opened up the doors to a lot of other aspects that used to typically reside within the telcos. But technology is technology, and it is just about finding the right use of a certain technology in a certain deployment use case. That is pretty much what 5G is enabling right now with respect to bringing in different categories of the architecture specifically designed towards different use cases. So enhanced mobile broadband, of course, is the first category of slice that 5G would be enabling. The second is obviously massive machine-to-machine communications, which is around the Industry 4.0 and the Internet of Things. And of course, ultra-reliable and lower latencies, because there are a lot of mission-critical tactical use cases that 5G is going to enable with respect to the higher data throughput that it enables. But then just throughput is not everything. You also need the connection to be extremely reliable. And on top of that, lower latency, such that certain critical applications could be running or leveraging such kind of slices. So in a nutshell, of course, 5G is definitely going to provide high throughput devices. That's kind of obvious for any wireless technology. And then there are obviously augmented use cases of such benefits of 5G with respect to high throughput. For example, remote cameras, connected cars, often where throughput is extremely high, there are high demands with respect to throughput. But then there are other applications with respect to low latency that's coming from the telco world, not from a operator world, with respect to Industry 4.0, with connected robots, V2X, where connected cars are coming into the picture. There's a lot of benefit with respect to the high throughputs and reliability that 5G is going to bring onto the table for telemedicine and remote surgeries kind of equations that are coming onto the picture. Now, when we are talking about 5G, we are talking about enhanced throughputs. Obviously, beamforming and the newer radio, which has been brought onto the table with respect to 5G, definitely needs a discussion. And that is the reason why you would see that when we have seen traditionally 2G, 3G, 4G, they always ended at the G. But with 5G, there is an NR also that comes along with it, because there are a lot of benefits that are coming in with this new radio that is going to be enabled by the 5G ecosystem. Of course, when we're talking about beamforming, a very critical aspect is the technology or the frequency band that we're talking about with respect to beamforming. So of course, we're talking about FR2, where beamforming finds a lot of use case with respect to ensuring that we are able to, kind of balance the line of sight issues, and as well as ensure that we are still providing higher fatter pipes, or a pipe that is going to enable lower latency and higher throughput, higher gbps of throughputs. Because if you look at millimeter wave or FR2, a lot of things are different with respect to FR1 or sub 6, where even basic things with respect to scheduling algorithm periodicities are extremely different from sub 6 to millimeter wave. So that, in summary, is a quick recap of 5G, and this is definitely going to be helpful in our following, material in this slide deck, because we are constantly going to keep on hitting back onto the salient features of 5G enablement and how these are going to find their place critically with respect to the telco deployments. A quick comparison of public 5G versus private 5G definitely needs a mention here. So just to quickly summarize, when we are talking about public 5G, this is generally suited, aimed, made for a typical mobile network operator that want to leverage the enhanced mobile broadband capabilities, providing much more higher data rates with respect to end user installation and commissioning. Whereas this is also a wide area deployment scenario with already a huge ecosystem of infrastructure of radio ecosystem. And of course, when we're talking about 5G, there are two modes of deployment, non-standalone versus standalone. So when we talk in the context of public 5G or in the perspective of public 5G, it is more about a non-standalone mode where a lot of leverage of existing infrastructure with respect to already deployed 4G radios are going to be used as an anchor node, as a master e-node be towards the NSA mode of 5G deployment. Whereas if you come to the private 5G domains, which is obviously going to start leveraging a lot of these newer, technological areas that 5G is bringing onto the table. For example, dynamic slicing, dedicated bandwidths provided to a specific slice, such that the users of that slice are kind of, given a very different treatment, because the architecture is inherently providing capabilities or enablement of such kind of capabilities. Of course, from a telco perspective, when we look at private 5G is kind of a big umbrella under which there'll be multiple verticals, but they're all telco centered versus mobile network operator centered. And that's why, since this is not an apples to apples comparison, this is going to open up a lot of independent network design and management, which is going to definitely drive down a lot of OpEx costs that telcos have. And that is one of the primary reason why, with respect to 5G, and the way 5G has opened doors to infrastructure augmentation, like running things instead of on bare metal on containerized form factors, is going to definitely bring in a lot of DevOps benefits that has typically not found its place in traditional 3G or 4G wireless technologies, but 5G is definitely opening the door for that. So the first vertical under private 5G or the telco that definitely 5G is going to aid a lot onto is Industry 4.0. Of course, there is a strong focus on machine-to-machine, communications and Internet of Things. So 5G is kind of an information and communication tech provider, right? And if you look at wireless technologies, wireless has always been an information and communication technology. However, with 5G, this ICT industry is finding its synergies with an industry 4.0 that is more focused over operational technology. So there are obviously alignment with respect to standard bodies who are fueling in all this convergence of ICT and OT industries. As you will see with respect to release 16, a lot of newer frame formats, newer scheduling formats have been brought in with respect to URLLC and release 16. TSN or time sensitive networking is again a very, very critical piece in the enablement of Industry 4.0 endeavors, wherein, as you can see on the figure towards the left, an entire assembly line with respect to a factory is shown, where all these different categories of devices, vehicles, AGVs, operation control, sensor, these can all be powered with 5G, and then they can all be, on the different slices, providing different kind of, capabilities with respect to their exact needs that is required and as an operational technology from the OT industries. And of course, 5G is cloud native, so a lot of data centers or on-prem centers are going to be hosting a lot of the industrial workloads in the containerized form factors, and then we just have to connect the dots between a wireless technology, opening up the pipe or the data towards all these different spectrum of applications which Industry 4.0 are going to use on these cloud native platforms. Plus, of course, since it is cloud native, there is obviously the added benefit of having a multi-site convergence. The next vertical under telco and private 5G is obviously unlicensed spectrum. There are a lot of progressive countries who have already started tapping into this unlicensed spectrum usage, where you define different tiers of operation, and then basically a certain spectrum of a certain country, which is mostly being used for first responders or for public safety use cases. That particular spectrum is basically opened up for leasing to whoever comes onto the table. And of course, there is a tiered priority basis based on which this spectrum is made available for public usages. And then this basically opens up the doors for a lot of telco and private 5G providers who might not have seen a lot of the spectrum share, because most of this is taken up by the operators. Now there is a newer full bandwidth or full spectrum, unused spectrum that is on the table, and it's opening up opportunities for private 5G providers, enterprises, and telcos to start leveraging that and then provide similar kind of capabilities or focused capabilities that are required for telco market on top of what's already available with the MNOs. Now, a typical use case of CBRS usage are in building with respect to education, tactical military, hospitality, and healthcare sectors. And of course, it will find its places in public spaces as well, such as in the entertainment field, like basketball courts, arenas, mining, and of course, industrial IoT has always been there and will definitely also be leveraging unlicensed spectrum with respect to private 5G. Coming to the synergies of 5G and edge computation, I must say this, that there is a lot of buzz with respect to this terminology, which is MEC, or multi-access edge computing. It started as mobile edge computing earlier. So in my opinion, this is a terminology. It is not a technology. It is a terminology which is going to encompass certain concepts that will enhance this terminology. And 5G is a technology. Now, really, when we marry the terminology of MEC with the technology of 5G, the end result of a deployment is basically an edge computation deployment. What you see on the left-hand side is a typical, operator deployment, where there are different aggregation sites which are available. There are core networks, IP aggregation networks, pre-aggregation networks, all the way down to the far edge, which is typically the term used when we're talking in the context of MEC. So there can be various form factors of network functions which could be available in these different aggregation size locations, depending on the exact need of these different aggregation sites. And that is something which is being enabled via 5G, because 5G has not only the architecture implicitly has created so many slicing and dicing or splits that it's basically opening up the doors to have a DU co-located with the RU at the far edge, and then you can take a CU which is containerized, not bare metal, and then it's hosted somewhere at a data center which is at the IP aggregation site. So you kind of create an MS to N kind of a model and try to leverage the economies of data centers that are typically available but not have been leveraged so much with 4G, 3G, and 2G. The next concept is obviously network slicing, which is key for 5G as a technology. And then of course network slicing is finding a lot of, or is basically enabling a lot of momentum with respect to telco and private 5G use cases. So really, network slicing again is a concept. There is no predefined way of enabling network slicing. All it means is that you have a bunch of resources available from a network when it is enabled via 5G. You have to figure out, based on telcos or based on a private 5G enterprises requirements, how do you want to slice off or slice and dice the available resources which is enabled via 5G as a technology to be made available to different slices and different users who are going to use these slices specific to their requirements. Again, cloud nativeness of the 5G is going to definitely aid a lot of execution expedition to all of this, because when we talk about cloud nativeness, we are talking about multi-tenancy, and all we're talking about is figuring out a way in which it is the least OpEx oriented way to have multiple slices of 5G to be orchestrated and instantiated on different levels of clouds, on different form factors, on different locations of a cloud native technology. Of course, under network slicing, you are definitely going to find different deployment use cases, again, which are going back to the healthcare, the gaming, the V2X, and the IoTs of the telco and the private 5G world. So net network slicing is kind of a common base which find its usage in on all the verticals of private 5G and telco usages of 5G, or I should say standalone 5G as well. So here we come to the session, to that point of the session where we've kind of touched upon what 5G as a technology is bringing onto the table, and then how it is being leveraged specifically towards the telco industry and towards the enterprise industries for private 5G use cases. Uh, a couple of last 5 minutes that I would definitely want to share on this ARM Dev Summit is about the Radisys 5G and our offerings. I'm sure Radisys is well known in the industry, but a quick couple of seconds. We are basically a company that's fueling in a lot of open telecom transformation solutions, where we are basically empowering a very wide spectrum of customers ranging from service providers to people who are looking at becoming digital experience providers. And from an offering perspective, we definitely have a very wide spectrum of offerings, starting all the way from the digital endpoints that you see on the left hand side, which are featuring the different smartphones, NCPs, and IoT sensors, going towards the network side on providing open and disaggregated access technology with respect to both wireless and wireline. Going towards the right, we do have solution offerings with respect to communications and core networks as well. And then, of course, to marry all these different pieces, we do have our network services offering as well that provides an overall end-to-end lifecycle consulting management for enable, integrate, and manage an operator use case or a digital experience provider's use case. Specifically on the mobility engine side or the open RAN side, on what you see on the screen is basically the different 3GPP splits that have been provided by 3GPP. And then on the right hand side is what we, our mobility engine business division provides as a product. From software protocol stacks perspective, 3GPP stacks perspective, and how we are aligned with different split options, the option 2, the option 6, and the option 7.2. So we have solutions in encompassing these three different split options with respect to 3GPP splits. This is a different representation of the same thing. So basically, we have software modules that find its place within the DU and the CU, predominantly from a 3GPP layer 2 and layer 3 perspective. Now, we are just not a company who's providing protocol stacks. We provide a lot more than just protocol stacks, which kind of comes out in this screen in this slide with the different shades of blue. So you will obviously find codecs and typical protocol blocks like RLC, NRUP, MAC. But apart from that, you'll also be finding some dark blue pieces, which are talking about different pieces like ONM, DU manager. There are different state machines. There are different applications which are driving the overall protocol stacks, the light blue pieces, towards the realization of the 5G network. And then these are all available with the different split options, which I was talking in the previous slide. And then, of course, from our solution offering perspective, we are aligned with FR1 and FR2 options. And then we kind of, I can definitely blow my own whistle here, that we are kind of those guys who are an integral part of the overall 5G ecosystem. We kind of have, integration and existing ongoing engagements with pretty much any and all layer 1 provider in the 5G technology market as of today. And last but not the least, since there is a lot of focus on openness and disaggregation that is coming with respect to 5G, we definitely concur and acknowledge and align with that overall philosophy of open. And that's the reason why Radisys Mobility Access and Mobility Engine Business Division is definitely an integral part of a lot of these ecosystems and consortiums, starting from ORANs, SCF or the Small Cell Forum, the CBRS Alliance, there are different Linux bodies, Open Network Foundation, Telecom Infra Project, and of course, the mother of all 3GPP as well. With that, we come to the end of this particular session on ARM Dev Summit. I hope to receive feedback and questions answers. Thank you all. You guys have a good day, good night, and a good evening. Bye-bye.